Hey everybody, this is Barry Mankin here with the Holistic Home Health Podcast. We're here today with Nathan Copeland of Copeland & Son, and we're going to get in the weeds here. We've got a two-part series we're going to do because there's so much to talk about with Nathan. Nathan is the top HVAC guy here in Nashville, and mechanical, you name it, combustion, he's the man. So we're going to have a really in-depth discussion. First, we're going to go over some of the basics, just for those of us that don't really understand the principles of HVAC and how integral it is and how crucial it is to our air quality in our home. So I always refer to this as the wild card of the house because there's so many variables going on, and the HVAC is a part of everything. It's the lungs of the home. And from our perspective, we're attacking everything from an IAQ standpoint. Nathan also has that passion, but he's also looking at performance. He's looking at efficiencies and all of the intricacies of that system to make sure that everything's working holistically. So I just want to thank you, Nathan, and welcome you to the podcast. I appreciate you being here.
Happy to be here.
Absolutely.
Thank you.
Yeah. So we're getting into summer.
We are. Yep.
The season is ramping up here. So my phone's been ringing off the hook. I'm sure yours has been too.
Same. Yep.
Yeah. So we've seen a lot of different things over the years, and we've developed a wonderful relationship. And again, our passion is about IAQ as well as what you do. So we're trying to find this balance between energy efficiency and air quality.
Right.
That's what we always talk about with our clients. So tell me, tell me about your business. Let them know, and then also tell us about how you got here.
So my grandfather and my dad started our company back in 1981. So from then, we've grown from those two up to a grandfather passing, and mom and dad ended up retiring. So my sister and I, we are into the day-to-day operations, and from that, I've been able to really chase what I enjoy as a part of this industry.
Right.
Is the indoor air quality, the health of the home, which I love to do. I love to go in and kind of see what's taking place, where the ball lies, measuring it from a performance standpoint, as opposed to just throwing everything at it and hoping for the best to what would stick. There are some that are out there that do that. They just want to everything to it and hope for the best. I'm not for that. So I do take each home in a different approach. Even though some of them have similar issues, that doesn't mean they're all the same. So I look at it from that way. So that's launched me into the performance side of the HVAC systems that are out there, looking at system performance. I can tell you the average HVAC system that's across the country is operating at about 54% efficiency. So Barry, for instance, what would happen is in this scenario, your system goes out, you call me up and you say, hey, the past 10 years, this system didn't perform well. I was hot in other areas. I was cold in other areas. I need a bigger unit. Not necessarily.
Right.
So you have to look at the house as a whole and look at it and go, okay, well, what's causing that to be an issue? Is it leaky windows, doors, switches, plugs, or is it just duct systems entirely that are designed improperly way back in the 70s? Are we still doing it that way? Insulation is a big key factor. Mm-hmm. Stack effect is a big factor on homes. And I would have to say that if the systems out there could deliver 90% or more of the BTU delivery of what the unit could do, there wouldn't be the comfort issues that I'm seeing.
Yeah, that's a good point. Let's talk about, there's so much wrapped up in that. Let's break that down a little bit. Explain BTUs to people.
So it's British thermal units. It is a way to measure air conditioning or heating, and there's a calculation to be able to come up with that based on where you are. So as an average in the AC side of it, we look at 12,000 BTUs per ton, and then that just equates to how much heating and cooling that you could then look at based off of a load calculation onto a house, and that is split up between a sensible, and the sensible is what we're feeling right now. Mm-hmm. The latent side is the humidity removal. So those two play a key role into sizing HVAC systems to a house, as opposed to one thing that we happen to notice is, house after house, you're looking at, well, that unit had a 2-ton unit in it. Well, let's just put back what was there. Let's just put back what was there. And this is 3 or 4 times over, and that's not the key. So if you look at a house and you're going, all right, well, how do we know what we're putting in there is the right size? So then we're going and doing a load calculation on a house to where we can use technology to scan a house and within 15, 20 minutes know exactly what the house needs.
Let's dig into that a little bit. And we're going to get a little bit in the weeds here. I know we said this was going to be basic, but we got to have a surgeon here. So so sensible versus latent versus when things come into play like static pressure, whether that's a restriction issue on filtration, whether that is ductwork that is crimped or blocked, and if it's just affecting one room. Then we get into dirty ducts that can cause restriction as well and airflow. Then we get into in a moist climate when these things happen, when those efficiencies happen. Now we get excess moisture. We get the system wears out. We get more condensation, if you will, and the condensation is not leaving where it's supposed to leave, out the condensation line,
right?
Which is to your point, what you said earlier is sensible versus latent. And if it's not going out there, it's going to be in the house. If it's going to be in the house and sweat because of lack of performance issues, we're going to get mold. So, and that's how this happens. So it's food and water. We always talk about food and water. And that's really all we're managing. But the HVAC is such an integral part, and there's so many different things to diagnose with that, which is so interesting. So most people don't understand, A, the terminology, B, what the goal is, because they just want to be cold or hot. They don't understand that the moisture level is such an integral part of it. So let's dive into why that happens, why moisture is such a big part, that removal rate is such a big part of that.
Sure. So if go back to running a load on a house, if you take a scenario to where you don't run a load on a house and you just assume whatever size was there before is the right size for it, and it's not. So a system that's oversized for a house will hit sensible, which is what you see on your thermostat first, not allowing it longer runtime to remove the moisture side of it. Now it will shut down prematurely. It might say 72 degrees on that thermostat, but your humidity is still there. And all of a sudden you're having, a 68 degree house with 65% humidity, and
cold and sticky.
That's not good. Not good. So that's why that's a key factor of making sure systems are sized properly. The other side is the ductwork side. So now each system that is manufactured has a static pressure rating on that unit that is sold. And typically those are like 0.5 inches of water column for that to function properly, to move 400 cubic feet per minute per ton. That's what's listed on that unit. So what we do is when we do performance testing is we'll go have that system running in operation for about 10, 15 minutes, measure that static pressure, and based off the curve chart the manufacturers have, it's literally a sweeping chart. You can pretty much plot what that is supposed to be on the airflow as a quick guide. Obviously, the best way to do it is with the airflow hood around all the vents, measuring everything, add those things up to see what your true CFM is. But the static pressure is no different than going to the doctor, getting the cuff put on your arm in triage, and figuring out where your blood pressure is. And from that standpoint, you have a range where we should be.
Right.
The higher the pressure, the lower the flow. Airflow is no different. Higher the pressure, lower the flow.
It's always path of least resistance, right?
Right. So if we can't move the right amount of airflow, we can't exchange the right amount of heat through refrigeration properly, and then now we have system inefficiencies.
And what goes with heat? Moisture.
Right.
Which means the moisture is not getting out either.
Right. Yep.
So when we talk about, this is where we get into the filtration side too, because I know it sounds like a lot, but if we just break these pieces down, I think it starts to make sense for people, because for us, especially for you, I mean, the terminology, exactly what the terminology means, and you're already seeing things holistically. But if we open this up and separate these categories for people to kind of understand the process of how it works, as an example, when we're talking about the static pressure, this is where things get a little dicey. Filtration becomes a big issue. So basically that increases that static pressure.
Yeah, it does.
Which means it slows the rate down of the air exchange, which also means the moisture removal. So whenever I see, and typically when I'm doing an inspection, the first thing I'm looking at when we get to the HVAC side is like, okay, let me see your filter. And they always, always, always have like a MERV 13 in there.
I know.
It's a 12 or a 13 or something because the marketing tells them you're going to have better air quality if you get my allergen filter.
Yeah, I know.
And A, I tell them, okay, your system isn't designed for this. B, it's not letting the moisture through efficiently. It's restricting the airflow. And you're in a moist climate, so it's food and water. They're putting the cart before the horse. They're removing maybe some more of the food for a certain amount of time, but they're restricting the moisture, which is the main job of the HVAC. It's not to filter. That's not what it was initially designed for. So let's talk about how that works with filter, because there's so many options. And second episode, we'll get into some of those options. But like just a regular 1-inch filter, what does that need to look like?
Man, that is a loaded question. So if you're going into performance testing and I get this question asked quite a bit, well, what kind of filter can I use? Well, right. to know that for sure, the best way is to take that filter out, put the grill back on, turn the system on, measure static pressure, and see where the ball lies.
Right.
Most of the time that we're seeing high static pressure duct systems that are out there, they cannot use a 3M filter from the orange store or the blue store. They just can't.
Yeah.
I have to look at them from that standpoint. If they're not willing to do any ductwork modifications whatsoever, they just need to use a standard 1-inch fiberglass filter that catches rocks and golf balls. I mean, there's the budget's just not there to use it when you start subtracting that off.
Absolutely. Yeah.
But if you're able to do duct modifications for it, we just oversize to accommodate for that filtration. There's so many different facets that are out there for filtration, from just that fiberglass filter all the way up to MERV 16. And everything in between. So I like to look at it from, if I have the budget to be able to do that, I want to look at ductwork modifications, going with the best filtration system that's available. A friend of ours, John, makes one of the best filters for MERV 16.
John Ellis. Out there. Shout out to John.
I know, he's good.
The man.
Yes, he designed that. And I've tested the performance on it, and it's amazing.
Yeah.
One of those that actually does what it says it's going to do type filter. But I just have to look at it from that standpoint first. Ball lies, look at suggestions, offering solutions for that from a top end of that type of filtration all the way down to just a standard type filter is the way to do it. But trying to listen to the homeowner's needs to know, well, why do they need filtration to begin with? I mean, does every home need John's filter? I would say yes. I'm convinced. I've seen enough over my near 25 years to know, man, that is...
Well, it's kind of like radon. There's no healthy level of radon.
Yeah.
How much debris do you want to swallow? How much do you want to breathe in? Like, that's your highest level of exposure to whatever's on that debris.
We have two options. We either invest in high-end filtration, or our lungs will do it for us. While we're
You're
sleeping.
The filter. That's what I tell everybody all the time. We're the filter.
Yep. Especially sleeping. So, I mean, you got to think, even though you're dormant for that period of time, whatever's in that atmosphere, you are taking that in.
Yeah.
And you're trying to filter that through. And it's just... it's not a good thing to do that. But looking at filtration, I would start top end. And then if can't meet budget that way, there's other alternatives we can go down to be able to still get something better than nothing. Right.
There's this tension between the energy efficiency versus the air quality, but there's so many factors. So you were talking about how most of these homes are, you said, around 55% efficient. Right? So that's what we call a D-. If you're going to pass a test when you build a house, and this is regulated by who?
Well, this is just testing through the NCI's protocol, and that's National Comfort Institute. So they gave us a while, nearly 20 years ago, a way to go into a system and turn that on, take measurements on it, and calculate BTU delivery into that house. That's subtracted for what the manufacturer says that a piece of equipment can do. We math that out. On average, that's what we're seeing on duct systems performance, which is pitiful.
What do you see in the industry that's related to? More of leaky ducts, or I guess it depends on the age of the home and how many people have had their hands in there, or is it is it always sizing, or is it both?
I see more sizing problems today, no different than nearly 25 years ago when I got into this. People are still sizing improperly, new construction. And we're seeing a lot of things that, absolutely. It's all about
cheaper,
cutting cost. And the other side is just as duct systems age, 15, 20 years max is what you're going to see life expectancy. Insulation breaks down in crawl spaces.
Yeah.
And then you're just seeing a lot of that condensation happening from that, which some of the other guys that have sat in my place too are in that same space. We're adding more fuel to their fire from condensation and more moisture, which is not good either.
Yeah.
So I would say both. If I had to pick my rather, I've been asked this question a million times too. What would you rather have, 20 SEER equipment, or would you rather have properly sized system with right filtration? And I would always lean that way. System performance, better filtration. I don't care if it's a 14 SEER single stage type system. If that's all they can afford, and I have that budget of a 18, 20 SEER system, I would rather see them go on the lower end of equipment, and I'd rather see them spend the money where the lungs are of that. Oh, absolutely.
Yeah.
All day long.
So explain SEER. What, again?
That's just a seasonal energy efficiency ratio.
Okay.
Now, it's just something the government come up with, miles per gallon, if you will, for our industry. I don't buy it. It's more of calculated than it is true system performance in the envelope of the house, because each house is different and each home will perform differently. That is no different than just thinking of, well, this truck gets 20 miles a gallon. Well, what's that truck get towing a car? I mean, it's different. It's the same truck,
right?
But it's under different strain.
So SEER rating is basically you're looking at the energy potential of savings on a system, and the better that is, the better your potential of energy savings, as long as everything else is in place, right? So you may have like a race car engine in there, but those tires are terrible.
They are.
So that I just want to put those things in context for people to understand, to say, okay, all these things have to be in place in order for the system to be higher in efficiency, and then the air quality is usually a good result of just being intentional with the performance. It's so interesting that the performance itself also gives us those air quality results that we want. Right. So that's really, really cool. And I don't think people understand the intention of the terminology whenever they're just buying they just know better, good, better, best, but they don't know why.
Yeah, and a lot of guys will sell them on that higher SEER equipment that's out there, because you get into two-stage, you get into modulation and all that type of components that are out there. But you have to think, Barry, we're 10 cents a kilowatt hour. Mm. And to go put a $30,000 system in a house, and that system's going to last, what, maybe 15 years, if you're lucky? Yeah,
electric for sure, yeah.
Yeah, and if you have to look at, all right, what is that system going to cost you initially? Even if you finance it, doesn't matter. Mm-hmm. And then you're in hopes that system will have no breakdowns, no failure whatsoever, no catastrophic failure to get that potential savings. I would just rather see all that budget money roll over into something that will be there for a while, not just something that can just rotate out. Yeah,
no, that's a good point. So this is where, the layout, the efficiency of the design, and the sizing of the ductwork is so much more important. If I'm hearing you correctly, it's so much more important than any other portion of that system.
Right. The most important day of a new system installation on an existing house is the day of commission.
Okay.
And if that's not done right, you're setting that system up for failure. So what will end up happening is, I've heard a lot of times in homeowners, they think, well, that's just a piece of junk of equipment. And it had nothing to do with the equipment. Yeah. It was the strain that it was put under from day one.
It's going to fail.
Yeah, it will fail. You're setting this thing up for failure.
Yeah.
And how is it the manufacturer's responsibility to keep replacing components on something that is put under such strain? Yeah. My opinion, I don't think it is, but the manufacturers, that's such a small percentage, they'll just eat it anyways.
Well, you figure, again, we already have a D- from a sizing standpoint. The layout becomes part of that process. Now in Tennessee, we have really, really nasty weather we're trying to condition in the summer. Most of these components are laid out in an attic or a crawl space. So depending on the environment that those components or that ductwork is in, then it becomes an insulation factor. It's an airflow factor. So now the temperature differential between what the space that it's in to what you're trying to deliver is a huge part of that. That's where it kind of comes into my space, where we're trying to evaluate, all right, what's the environment like that the ductwork is in? If you're just like getting well water or getting water from one part of the house to the other part of the house, if that temperature swing is this far, it's not going to perform and get that deliverance of, okay, I want a certain temperature by a certain amount of time. And how long does that take for that to happen? And then what are you losing in those non-controlled spaces, depending on that insulation around that? And then you get to sweat as well.
Oh, you hit dew
So
point.
like all those things, yeah. So dew point becomes a big issue. We talked about that with our last segment where we had Don Canar here from Blue Chip. We talked about dew point a lot, and that's big in the HVAC side because, again, you're competing for removing the available moisture so that you can stay away from dew point all the time.
Yeah.
I was literally just in South Carolina. I don't think I told you this, but I was in South Carolina with a builder, and you'll find this interesting. This builder is so passionate about air quality to stay away from dew point that he's got chases for all the HVAC ductwork to be within controlled space only. So even in an attic, he'll make chases that are conditioned separate from the rest of the attic space just for the lines so that they can have their own space that doesn't get contaminated. It's really interesting stuff.
Yeah. I wish that more would do that.
Yeah.
I remember seeing a guy a couple years ago think of the same concept, staying within that envelope of the house, all the ductwork inside. And it makes sense because an attic installation is completely different than a crawl space. So crawl spaces, as you know, they're going to be cold, dark, damp. And a lot of them are not encapsulated or dehumidification control is down there whatsoever.
Right.
And it doesn't take much to hit dew point on ductwork. And what people don't think either is, say you do a duct renovation in a crawl space that's uncontrolled whatsoever. Well, how long is it going to take before degradation takes place on the insulation and then the weight of that ductwork on the insulation? And now from 9 o'clock to 3 o'clock underneath, it's
You
raining.
got a belly full of water.
Oh
yeah.
man, all the time.
Yeah.
And even though it's galvanized steel supposedly,
Right.
at some point it's just there's holes all the way down through it just from all the moisture. But to where is in an attic, you can have BTU loss just because the attic's so hot. I mean, the hottest attics I've seen is 160 degrees.
Yeah.
And, we're leaving the unit itself at 52, 54 degrees. Well, by the time we get to the register, we're in the 60s.
Yeah.
So
exactly.
now on a hot day, you're like, man, alive, this thing's taking, a whole lot longer to cool this down than what it was before, but two different areas. But we have a lot of houses here that are in that scenario, a bad crawl space and a hot attic. Well, I mean, the house is struggling.
Let's talk about that worst case scenario. So we have, and just break that out, because this is where I don't think people understand all the different points that contribute, because I tell them it's always percentages of influence, right? And we can measure that stuff. So it's 100 degrees outside. Let's just say it's 100 degrees. 100 degrees outside. We have a system that's 15 years old, maybe had some repairs or had some, rodents or something like that. So we have some holes, and some bacterial influence, that sort of thing. And now those holes are losing more BTUs. Plus, when the system is off, the pressurization of the house is drawing debris in from non-controlled spaces, affecting the system, which we'll get into in the next segment on some of this stuff. But then we get, again, the hot attic, no ventilation, whatever the case is. Either way, we have that temperature differential. Then we have a crawl space, and maybe that crawl space, same scenario, we have some holes. Or the seals have, because of the moisture, the way it was taped or the way it was sealed up, they have lost their seal, and now, again, we're getting that same influx, not just from the up above, but below. Maybe one's a package unit. There's a lot of package units that have influx from grade where water comes down there and gets into the system directly, plus the outside influence of the coils themselves. So all of these factors kind of come into play on a system that's already at 55% when it starts. So because, again, they build them for a D- because codes don't require performance.
Not at all.
They just require a checkbox. And if they're already starting at that level of performance, you already have this downward trend. Now, as things happen, things just get worse and worse and worse. And we get back to that food and water again. Now those things are going to thrive. So let me back up and say, okay, if that's the worst case scenario, do you come at trying to fix the problems, or if it's bad enough, are you saying let's just start over?
Yeah, if it's that bad, it's we need the budget to be able to do that. And you're talking everything from that scenario. We're talking remediation from the crawl space side of it, encapsulation.
They've got other issues they got to take care
Man, I know. It's trying to figure out, all right, what kind of stack effect do we have on the house? What's causing all that influx of moisture into that space? And then we're trying to overcome it. So certainly duct renovation, running a load calculation to make sure what's actually there is sized right, or is it oversized? I'll tell you, listening to the homeowners and having that survey with them to get an idea of what they're experiencing, because they live there more than anybody else will step foot on that property.
Right.
So once you have that information and knowing, well, there is humid issues, or we have some, there's just dust like nobody's business on all horizontal surfaces. We're seeing those things. I'll tell you, just from what I have noticed, if you were to take a thermostat, turn it off, turn the fan in the on position, and monitor your humidity rise, just to show you how leaky a duct system is, you'll see something happen in 15 minutes.
Yeah, that's really interesting too. I've seen this, and there's other issues with that, but I probably have 6 or 7 clients a year in the summer where they have mold on all their stuff in their house, and and the aspen levels are just off the charts. And they're like, I don't know, but we have this moisture, and I've got mold growing on my stuff. Well, when I look at their HVAC, and it's every single time that this scenario happens, they're in the 60s. It's 90 plus outside, high relative humidity in the south, right? And they're just not comfortable, so they're pushing it in the 60s, which it should be around 74, 75, if everything's working as it should.
You can still get down 70 degrees. I mean, if everything is sized properly,
you can do
it.
Okay,
yeah, you can do it.
But you have these scenarios, and then I look on their thermostat, and not only are they in the 60s, usually in the low 60s, but their fan is in the on position. They're thinking that they're making it work better or work harder by just keeping it on all the time. Because they don't know that they're trying to remove moisture. They just think they're trying to get more comfortable. Right. They only think of comfort, but it's directly related to moisture. And other than it not allowing that coil, it just dries that coil out. The fan's on all the time, right? So it doesn't allow it to condensate effectively. It keeps that temperature differential away from that, so you don't get the condensation where you want it, so it can pull it out. But you're also doing the other, So like, I can't tell you, it's probably 6 or 7 times a year. And all of their stuff has to get remediated. They have to throw things away just from the operation of that.
Yeah, I've had that question asked so many times over my career. It's just, well, should I run the fan in the on position? Well, I'm 2 different ways. If we do a duct renovation with right filtration, it's going to be sized, it's going to be sealed, and then you have filtration to catch all the food source there. Absolutely. Let's keep scrubbing 24/7 throughout the house.
Yeah.
But in this scenario, it's a disaster. I mean,
the system has to be specifically engineered for that.
Right.
And how often does that happen?
It's rare.
It's rare.
If I can get my hands on it, it'll be done right.
Exactly. There's these concepts. People say, "Oh, run the fan." Oh, run. Keep it in a certain moisture level in your house, or just keep it completely dry, only, right? And from an environmental standpoint, again, that's this holistic approach to say, not always. Not or the house needs to breathe, or it needs to be tight. All these concepts, it doesn't apply to every house, in a specific way, but it's the prescription to do the engineering to say this, in this scenario, you can do that. That's really, really important.
Well, I've been in some of the older homes all the way to newer construction today, and I can tell you, you've probably noticed this too, but some of the houses that were built in the 1900s, they leak like the sieve. I mean, it's just awful how worse they are. But what kind of microbial growth do you see?
Right, not as much.
No.
Unless you have direct water, it's not there.
You don't.
Yeah.
They breathe. Yeah. And so what did we do? The government thought it was a great idea. Let's go seal up these houses. Let's make them airtight. And then we're going to force systems to have fresh air makeup. And then we need dehumidification. And then now all of a sudden you're thinking a system that back in over here to where it's just to change the system out alone to where now we're having to have fresh air makeup. What kind of additional cost are we adding to the home for this HVAC change out just to make all this happen?
Right.
It's adding another 10 grand or so to get all that done right. So we've made them more tight, and now we're having to bring them in mechanically fresh air makeup instead. So
Yeah.
there has to be a balance.
Exactly.
And
Yeah.
I've read stories up north where houses were so tight and underventilated that you would have family would go downstairs for a bit to grab whatever, and those people would pass out from CO2 poisoning.
Mm-hmm.
There's just too much carbon dioxide
Yeah.
and not enough fresh air makeup to dilute it.
Yep.
So I mean that's a thing.
Oh, absolutely. Especially in today's construction, it's a thing for sure.
Let's make them super tight. That's just again goes back to we're seeing more mold issues in homes than we've ever seen before.
It's a big petri dish. That's all it is. I mean, and so the potential is there, and it seems to me that there's nothing in the middle that's available. Like, since we want to be comfortable and we want HVAC, once we introduced HVAC to homes and they didn't breathe, and the lumber is different, and the materials are different that we're using in our homes that are more susceptible to mold growth and to hold moisture, everything in that middle that most people can afford to do, or they think they're making improvements on their house,
Right.
there's an equal and opposite reaction to everything, right? So if that law is true, which it is, what are those opposite reactions? And can we measure those effects so that we know, okay, if I do this, then that's going to mean this. But we don't think that way when we're just trying to make improvements for our homes because we're chasing money.
Right.
We want to save a little bit more money, but we pay for it in air quality always.
Yep.
So it's either all or nothing. It's just like a crawl space. I tell people, hey, if the crawl space is healthy and it may be older, but other than isolating the floor from it, if it's breathing, well, you don't need encapsulation. Like, it depends on a lot of different things, but is encapsulation great? Yeah, it is. However, do you need it? And if you've got older lumber, you don't have any moisture issues around the house, you don't have any, anything coming up other than a good vapor barrier and that being sealed, let the rest of it breathe.
Yeah.
But the moment your moisture levels are being retained in that space, that's what a hygrometer sensor is for, just to tell you, hey, what does it need? The big indicator is obviously if you have any growth over time. But, at that point, it's like, okay, now we got to go the opposite direction. But there's no in between.
No.
It's either this or this. And the envelope is no different. The difference is going to be what are we stuck with? And how again, it's not the what, it's the how. How are we going to have mechanical solutions for those problems? And without a good diagnostic, everybody's just throwing money at something and making things worse, it seems like.
Yeah, in hopes that it works. So
Right.
in a scenario where you're looking at a crawl space that's in dire help, and the homeowner has let's say wood floors, and you're standing in the foyer, sun's coming in through the back of the house, you can see all the cupped edges of the wood. You know what you're getting into in the crawl space. It's going to be a humid crawl space.
Yeah.
What people don't realize is, guess where all that moisture is going? It's coming from the crawl space up, and then we're having to run the AC to get rid of it,
Yeah.
just for it to keep cycling. It's ductwork sweating, adding that fuel to the fire. That moisture is rising. The floor is showing it. It's
Which
screaming
takes us
for help.
away from performance. Now you're not just dealing with the normal
Right.
moisture that it's calculated for, but it's the excess moisture influence.
It's coming up.
Yeah.
The other side of the indoor air quality is the VOCs. So if you fast forward to homes that are being foamed in, and those two chemicals are mixed at the nozzle of the gun,
Yeah.
and we're spraying addicts and the rest of that. Now we're off gassing for another decade, and we're having to deal with that. And the only way to get rid of that is through dilution too.
Yeah.
Well, what's that going to cost the homeowner?
Yeah.
And how long are those fresh air systems going to last before they have to be replaced on top of the refrigerator that's going to go out, in 6 years, and then the HVAC? I mean, you see what I'm getting at? It's like the long tail of all these mechanical things. It's like you can never seem to get ahead because all these things you have to keep going.
But don't worry. As bad as this sounds, we have solutions.
I know, but it's man alive. It's just what we see. That's out
It
there.
is.
It's awful.
And again, we chase comfort, we chase money, and we pay for it in health. So we got to find a balance there. And there's like levels of this stuff, right? But it has to be very strategic. And this is what we try to sell people on, to say, okay, what's our order of importance for your money once we get into these things? And so much it comes into dealing with the HVAC side, because it's the main delivery of air for the home. So to me, other than isolating sources and dealing with those sources where we get a remediator to come into play if we need that, or we do some sealant packages and isolate things and clean things. It really is what is the next level of our main exposure, which is always air. Before your food and your water, to me, it's a bigger epidemic. And so if we're doing that well, again, there's stages of this, and as long as that system is properly sealed, cleaned, and engineered appropriately, we can get, again, those levels of efficiencies. But I don't really think people understand the importance of the sizing of that ductwork as part of this process.
It's no different than, like I mentioned, you go to triage, they measure blood pressure.
Yeah.
So if you had high blood pressure, enough to spook you, and then you're like, well, wait a minute, what's going on? Well, they scan you and go, hey, you've got clogged arteries. It's not good.
Yeah.
It's no different in duct systems. I mean,
Yeah.
if these things cannot breathe, they will quit.
Yeah.
And it seems today that so many systems now are just thrown together. All these manufacturers are picking from the same parts bin, and they're just not lasting like they used to.
And what is that standard? What is the standard that say it's a new home today?
Yep.
Let's talk about the Manual J. Let's talk about their standard for getting to a certain level of efficiency by the code requirements here in Tennessee.
So you're looking at 14 SEER, bare minimum on efficiency,
Okay.
which is just a bare minimum miles per gallon. On the furnace side of it, you're looking more at just 80% on efficiency there. Obviously, you can get a whole lot higher. On duct systems, on new construction stuff, it really doesn't matter. It doesn't matter what size it is. I'll give you this. So if we take just a brand new house, let me put in the right sized unit, and let me undersize the duct system by 3 tons.
Okay.
I will pass blower door test all day long.
Okay.
So that's what they're going for on the new construction side. Say, hey, we need to do a duct blaster test too. And what that does is they'll put pressure onto that duct system to see how sealed it is. They'll run a blower door test on a house to see how sealed it is. What in that does anything for performance of the HVAC?
Right. Yeah, exactly. It's not isolated.
Not a thing.
Yeah.
I can get away doing that.
Yeah.
It's bad on our reputation to do so because systems will quit.
Right.
But I can pass those 2 things with flying colors and look good on paper. But it doesn't mean it's going to perform well.
So you're talking about the metric that they use to pass that code requirement has nothing to do with isolating that system and how sturdy it is as far as performance.
Not at all.
Interesting.
You have to go and do performance testing on it, measuring static pressure, BTU delivery, refrigeration. I mean, all that is encompassing that performance.
Right. And I don't think people understand that or realize that. That's how they get to where it's a new system. It's supposed to work good. But if those standards aren't out there and how those standards are passing to get that system to where, it's approved for the homeowner, and it's a new system, so it should operate as intended, right? I don't think people really understand that they're literally getting a D-.
No, I'm working on a job now. I've been working on it for, I'd say 3 months helping this guy.
Yeah.
So brand new house, brand new build. I go out there, do performance testing. He was having some issues with it, and to the point of, hey, this doesn't seem to be right, but let's go through it. So we ran our performance test on it, ran the static pressure, and it should be a 0.5, and we were running a 2.09. So if we were to go in to use, say you go into triage, and they say, Barry, your blood pressure is 4 times what it's supposed to be.
Right.
You'd be in the ER.
Yeah.
So what will end up happening is it's a trained system. So trained system would try to run under that type of design. Well, what do you think will happen in 5 years?
Yeah.
We're slugging the compressor with liquid so much so that it'll probably quit.
Yeah.
Homeowner goes, well, that's junk. You're going, oh, look at what it was put under. But it passed blower door. It passed duct blaster.
Yeah. Why do you think this is?
Oh, man, that's a good question.
We can we could talk conspiracies or whatever you want to talk about here.
Man alive. So, yeah, you'll go down that road. Man, I don't know. I don't know if it's just a lack of education, lack of companies wanting to take and invest in their guys to be able to understand this, but I don't know why that is. I mean, we've been a performance contractor for over 20 years, and this is not new. And what we know is not proprietary. It is common knowledge in our industry, but yet nobody wants to apply it.
Yeah.
That to me is just, I don't get it.
And, it's a lot like water, too. I mean, just the way water is delivered and the way air is delivered is very, very similar. But like the size of, PEX at, just a quarter inch difference makes a huge difference in performance. And the same, I would say with ductwork, with the Flex anyway.
Right. Yeah.
So with Flex, it doesn't cost that much more if you're on the front end of this to do it the right way. You're already doing the labor. The material isn't that much more expensive. Like, why not?
Man, you got to think in new construction, everything is about money. It is just typically hire the
Bottom
cheapest guy.
line, yeah.
And we just don't get into it. Now, if you were to go to build a new house yourself and I can work directly with you, absolutely. But to go work for a GC, I'm out.
Yeah.
Because of that reason.
Yeah.
And that's just a
Because you're bidding against two other companies that are going to do the minimum standard.
Yeah, and just let them go. And here's my card. Call me back after the first year.
Yeah.
And that's what we see.
Right.
And it's just pitiful that we've stooped to that level. It seems like plumbers know how to price jobs. Electricians know how to price jobs. But
Right.
HVAC guys want to cut throat everything, and I just never understood that.
Yeah. Yeah.
Not to say that what they're doing is subpar, and they may just not know, but it's like, I mean, come on, this stuff's been out there. I mean, we've had AC for what, over 130 years?
Has it been that long?
Yeah.
Man, I didn't know that.
Everything what I know is not new.
Yeah.
It's just being applied.
Wow. Interesting. This is good stuff. One other issue I want to talk about before we get to our next segment here, the refrigerant efficiency. Let's just touch on that and talk about when that changed, why it changed, and what you think the result of that is.
Mass chaos.
Yeah.
It's like if it's not broke, don't fix it.
Is it at R45?
We have
What is it at now? Because it's changed twice.
So there's two that we can go off of now. The first one's R454B,
Right.
which is a blended refrigerant.
Okay.
And the other one is R32.
Oh, okay.
And manufacturers get to pick what they want to do. For instance, Goodman, Daikin, Amana, those guys are using R32. Everybody else seems to do R454B.
And this changed from R22.
410A.
Oh, 410A.
Yeah. So in 1996, that was the change over to 410A refrigerant. And then from then till up until I'd say now we're looking at having to change rapidly. So R22 had to phase out from 96 on.
Right.
And then they had that cut off, and then 410A stepped into its place.
So this has been happening strategically.
The 410A shift over to the new stuff is very drastic. So what's happened now is there's now a shortage of R454B.
Okay.
And so now you're looking at manufacturers are buying it up to put it in their equipment, and we need some to do the startup side of it for the changeouts. Mm-hmm. We have it, but getting is getting expensive. So as the supply's low, demand's high, obviously you know what's going to happen.
Yeah.
And once they achieve that dollar amount, you think that's going to go back down? No.
Right. Yeah.
No, it won't. So those type of changes, we've done some system performance testing on those already, and we're seeing very similar to 410A. So I mean that's encouraging on that side of it. Mm-hmm. But looking over R22, that was a great refrigerant. EPA made their changes to hit global warming potential.
Right.
And I don't buy that either.
Yeah.
But, I may shoot myself in the foot by saying it, but I just don't buy into that. It's like we were at, and this is between me and you. Nobody's watching.
Yeah, nobody's watching.
Nobody's watching. I ended up doing a job for a guy this year that retired from DuPont.
Uh-huh.
And so I asked him, I said, so tell me, it's just me and him, me and you talking like this.
Yeah.
Why the change?
Yeah.
He goes, oh, you want to know why the change? He said, DuPont's patent ran out. And now all of a sudden, since that ran out, we need a new standard to change. He said, now think about it. If you had something that was set in place for so long and it's not needed, that demand's not there. So how can we create that demand?
Yep.
All of a sudden, the patent ran out. Now we have to make changes. Now all of a sudden, you've got a system at home with a leak. There's no 410A refrigerant. Now we have to buy new. It's going to cost you 5 figures. And you're going, I wasn't ready for that.
Yeah.
Well, that's what we're faced with. Or I've already had these conversations to where, say last year you had an indoor coil leak out. Mm-hmm. We replaced it. Split system, obviously. Mm-hmm. Now the outdoor unit compressor failed. And you're thinking in your mind, cool, that's new. This needs to be changed. No, we've got to change that again, and change this to match. It has to match.
Mm-hmm.
Sensors have to be put on these systems because of their flammability rating to allow, when they do have a leak, to run the blower on those things to keep them dilution from happening to where you don't have an explosion that could take place.
And now, not only that, but we have efficiency issues as it relates to how it's pulling the moisture out efficiently, right? It's not as effective, which goes back to now is the ductwork size. Like if you're on that line, now your efficiency is less,
right?
Because you had to make the change, and now we have to reassess the whole system.
Yeah,
potentially.
I've heard some noise on that too, to where I've heard 10% less than 410A on B2 delivery.
Okay.
So I've looked at some manufacturers' numbers to see, okay, what a 2-ton was under 410A and what is that R454B under that same capacity to see. It's very close. It's very close.
Okay. So
not so much noise of what I was hearing in the very beginning side of, oh, we can't go that way. Well, we're going that way and there's no changing it.
So if you're already like bad as it relates to size, you're basically looking at the whole system anyway at that point.
Right.
So it's another percentage of potentially, making that system work harder because of all the same things we discussed before with sizing. Again, it always goes to sizing a ductwork.
Well, so system replacement at your place, and we run in and do a load. I need to know what that sensible requirement is and what that latent requirement is, and then we're going to cross that to what manufacturer says for that sizing to say, okay, you may have a 2.5 ton, but looking at the latent side, does it match up with what's today, or do we have to make changes or add supplemental dehumidification to make up that difference? Yeah,
this was where it gets a little bit in the weeds here. So we'll talk about that in our second segment. This is just like, I cannot believe we're already at the end of the segment. It's crazy.
It flew by.
Yeah. So Nathan, I just want to thank you so much.
Thank you.
This is just so informative. I wanted to try and keep this, even though we got in the weeds a little bit, like as basic as possible so people could like understand the basics of HVAC, what we're trying to achieve, how it affects our environment. And as far as solutions and that sort of thing, more complex systems, we'll talk about that here next. So thank you so much for watching, everybody. We'll see you again.